Hi, time for a chime video. So today I'm working on a really early Rittenhouse 8-note door chime. So this chime was sent to me by Katie, and Katie lives in San Mateo, California. However, it originally was in her parents' house when it was built in 1939 in Akron, Ohio. Recently, her and her brother inherited her parents' estate, and I believe they sold the house in Ohio, but she didn't want to leave the door chime there because she didn't really think that the new owners would probably appreciate it the way she does, because she remembers hearing it as she grew up in the house. So she took it down and brought it back with her, and then found me and decided to send it to me to have me go through it and clean it up a little bit, make sure it works properly, so she can put it up in her house. I did some searching around and I could not find a model number for this chime. The only information I really could find was one brief description, which said that it was first made in 1937, so that sort of fits in with Katie's family story. And we know it's a Rittenhouse chime because it says Rittenhouse on the label. This cover at the end here will mount back in this position right here to cover up the contacts. You don't see a lot of chimes like this, so this is mostly going to be an overview. Most of the work's already done on it. I left a little bit undone so I can show you a couple things about it, which I find kind of interesting. It's a well-made, heavy-duty chime, because back in those days door chimes were very heavy-duty. I don't think that they were too concerned about how much something like this actually costs and the effort that went into manufacturing it. Everything here is very, very heavy-duty, especially if you compare it with chimes that they made 25 years later. It uses this sort of classic Rittenhouse design where the solenoids, which are ones here and then 2, 3, and 4, they're at this angled design where they come out from the base plate at an angle instead of sticking out straight like NuTone did it. And this is sort of a classic Rittenhouse kind of design, and I think it was done that way to make the chime a lower profile so it wouldn't stick off the wall quite as far. But you see this a lot. And then we have this Bakelite plate here with all of the screws for the wire connections. This is a variable like a rheostat, which you can adjust. It would be the loudness control. It adjusts how much voltage the solenoid coils get, therefore adjusting how hard the plungers pop out and strike the chime, so you can make it louder or softer. And then here you have this revolving disc design, which does a couple different things. The way this operates is when someone pushes the button, this disc is connected to the motor that's back behind here, which I'll show you in a minute. And as the disc starts to turn, this notched area right here rotates past this switch, and it pushes up on the switch, which allows the motor to keep running after the visitor has taken their finger off the button. And then you have this springy wiper contact here, and the disc revolves and the contact rubs past each of these posts, which are connections to the solenoid, and that's how you achieve your 8-note Westminster chime. So it's 1, 2, 3, 4, and then a pause here in the middle where the big gap is, and then 1, 2, 3, 4 again. And it's a fairly simple design. It's not nearly as elaborate as other Rittenhouse 8-note chimes that I've seen. Especially, I worked on, the nearest to this that I've worked on is a Rittenhouse, what's often referred to as a music box chime, which I'll put one of these little pop-ups right here that'll take you to that if you're interested in that. It has a much, much more elaborate design than this does. And actually, in some respects, this revolving disc with the notch cut out and a switch here, this is very similar to what NuTone used in their chimes starting in the early 1950s, like 1949, 1950. In their K model chimes, they use, it's not exactly like this, but the concept is very similar. In the early 1940s, in the late 1940s after World War II and into the 50s, we're in the heart of what I like to call the chime wars, where you had a lot of fairly decent sized companies battling and vying for market share in the door chime business, because it was a new thing in those days. And I think there was a certain amount of stealing ideas from each other. So perhaps the NuTone design in the 50s was something that someone saw on a Rittenhouse chime, and it was long enough ago that we could sort of use the concept of it. I'm not saying they stole the idea, but it seems interesting to me that a chime that would have been made a decade later by NuTone uses a similar type of design. We go ahead and lay this down. so I can take the screws out. Everything here is very nicely done. All the screws are all machine screws, and they all thread into metal standoffs. This was obviously a product where the design was important to them. It was very early on. And for instance, the 3 screws that hold the Bakelite plate in place, they're all bevel-headed screws. And the holes in the Bakelite plate are all beveled to match the screws, so everything fits together nicely, and it's much more accurate than having round head screws. So once we take this loose, we can tilt this forward carefully, and what you can see on the back of it is the motor. So in this close-up of the motor, you can see it's a twin coil motor. So this is one coil here, and this is another coil here. And actually on this one, there's actually a label on the coil. And it says that it was manufactured by the Hanson Manufacturing Company, and they are located in Princeton, Indiana. And I looked them up online to see if I could find some information about this, and as it turns out, they're still in business today. And guess what they make? They make all kinds of really fancy high-tech motors that go in all different types of devices and products and things like that. And they've been in business since about, I think it was like 1903, which is really, really early in the world of AC motors. So what you have here, and I am not a motor expert necessarily, but what you have here are, if you divide it in half, you have 2 C-frame, or what are often referred to as skeleton motors. So this coil and this half is one motor, and this coil and this half are another motor, and then they're paired together, and you have 4 sets of poles. So this one and this one are for this motor, and this one and this one are for this motor. And I couldn't really find anything that talked about the design of a motor exactly like this, but I believe that it was probably done to give the motor more torque than if it only had one coil. But that's just a guess on my part. These type of synchronous motors are very common in small, what would be considered household appliances, things like clocks and turntables later on and things like that. And also in door chimes, NuTone used Telecron motor assemblies, and somewhat like that down here, where it's really hard to see, right here, is a gear reduction drive assembly. So the motor runs the gear drive, and the gear drive runs the disc on the front. And that's how it works. But this is quite an elaborate design, and then of course you have all the wiring that makes up all the circuitry to make the chime operate the way it does. This is obviously, again, a sign of high quality, and I'm sure that this little motor for back in the day was much more expensive than your average motor that you could have put in a door chime. Now, we're looking at the back of the chime, the part that would sit against the wall, and what you're looking at are the back ends of the 4 solenoid tubes. So there's 1 here, and 2, and 3, and 4. And this has a very unusual design. I was actually surprised when I turned it over to look at it the first time, because the way these are assembled, and I left the last one. This one is still empty. See, I could put the screwdriver all the way in it. These have already been taken apart, cleaned, and reassembled. But what you have here is you have this, what I think is a fairly elegant design. Instead of having some kind of rubber cap or something over the end of it to contain the cushion and the plunger and the spring that are inside, it has this little brass, what is essentially a cotter pin, and it's slid through a hole in the tube here, and then it comes out the other end, and then the center has been deformed, and I'll show you how to do that, to hold it all in place, and that's what keeps it all inside. And I think that's sort of a really elegant way to have done something like this. Let me show you the steps it takes to service something like this to make it function as well as it could, because you have to remember this is from 1939. Now, one of the things I've already done, which I've shown in other videos, is I've already cleaned the inside of the solenoid bore, which is right there. And if you look carefully, you can probably just get a glimpse a glint of light off of it to see that the brass is all shiny now. So I simply honed that out with some 2000 grit sandpaper to remove all the oxidation and dirt and grime that had built up over the years. So now it's clean and smooth and ready to have the plunger put back in, but we still have to deal with the plunger part. So let's do that now. So here's plunger number 4. To go along with plunger number 4, we have spring number 4. We have cushion number 4. We have brass washer number 4, and the all-important cotter pin number 4. And this makes up the internal parts of the number 4 solenoid. So the first thing we're going to do is we're going to put all the little pieces back in the tin cup, because as I tell everyone in these videos, if you don't contain your parts, you're going to lose them. So the first thing that I noticed about these, and these are sort of classic Rittenhouse plungers. These are the same types that were used in the music box chime that I repaired, and they're fairly large. They're larger diameter than average, I think because it was the early days of chimes. They have this nice step design for the tip right here, and on the end of the tip it has what is most likely leather or felt or something like that. It looks very much like the end of a well-used pool cue. So we're not going to mess with that because I don't have anything to replace it with, and I don't think it needs to be really messed with. But these need to be cleaned up because they're kind of grimy right now. And you'll notice that they have sort of a copper color. It is a ferrous metal. It is some kind of metal. Ferrous means it's magnetic. But it has, I think, a copper coating on it. And I think that was probably done to help prevent the steel from rusting or something like that. So we need to shine these up. So we're going to do this the easy way. This is the way I like to do this. I'm going to use the cordless drill. I'm going to put it in the chuck. And I've got my 1200 grit sandpaper. And all you have to do is carefully wrap the sandpaper around the plunger and turn the drill on. And that's about all it takes. Now, when I take it out, you will be amazed at the difference. The shiny part up here is the part I just cleaned, and this is the old part down here. So that's all it takes to really clean these. We're not going to be concerned about the tip where the pad is, because it's the part that slides in the solenoid tube that matters. You don't want any extra resistance. You want it to slide freely, and this part does not. So we're not going to mess with that because we don't want to fool around with the tip, because if you damage it, then what are you going to do? So now all you have to do is turn it around the other way and do the other end. Like that. Now the whole thing is shiny, except for the end. Now the end, the thick end, not the tip end, but the other end, it is oxidized, and although it doesn't really interfere with how it works, I like to clean it up anyway, because if you're going to do a job, let's do it all the way. Now, once you've done that, we'll put this on the rag here for a second, and we want to take some lighter fluid like this. This is real Zippo lighter fluid. And when I say lighter fluid, I'm not talking about the kind you use in your barbecue. I'm not talking about white lithium grease. I'm not talking about WD-40. I'm not talking about some stuff that you have in the garage on the shelf from 1969 that the label fell off of and you really don't know what it is. I'm just talking about regular old lighter fluid. This is the go-to stuff for cleaning parts like this. And once they've been cleaned, I always put a little bit on here. And when I clean the solenoid bore, I put a little bit in there also. And as it evaporates, it leaves the finest amount of oil on the surface of the metal, which allows it to slide freely and keeps it from rusting or oxidizing or whatever it is it might want to do. Once that's done, now we need to reassemble this so we can put it back in the chime. So the first thing that goes on is the spring. Now these springs are unique because this end of the spring is small and fits over the tip, and this end of the spring is large and fits inside the solenoid bore, because as with many chimes from the early days, they put the springs on in the front. And for some reason, somebody thought that was a good idea. NuTone did that, Rittenhouse did that, a lot of chime companies did that. So these act as compression springs. So when the solenoid is not turned on, it's like this. And when the solenoid is activated and it rockets the plunger forward, it compresses the spring to build up force. And when the solenoid shuts off, the force of the spring shoots the plunger back. This goes back in the solenoid bore like this, and it just drops in, which is what you want. Very simple. Now we have to put our cushion. Now, this is like the world's best, highest quality cushion I've ever seen. This is made out of some sort of probably natural fiber material. It's probably all of 1/4 of an inch thick, and it has a nice little hole in the center of it here, which I think acts as a vent, like NuTone did that also to not trap air in behind the plunger. And this goes into the solenoid bore like this. You just push it in there nicely. And then, to protect it, you take the little brass washer, and that goes in next. And then you have to push it down a little bit to seat it in there. It'll find its own resting spot after you activate the chime. And then the last piece you have to put in is the little brass cotter pin. Now these cotter pins were all installed with the round part, this part, towards the bottom. That's how it was before I took it apart. And we're going to put it back together the same way, because if that's the way it was done when it was new, then that's the way we're going to do it today. So what you do is you slide it through one hole, and then you carefully wiggle it around. And of course it's easier to do if I wasn't making a video, but I am. And then you've got to get the ends of the cotter pin through the other hole. And of course it's easier if you can actually see it. So I'm going to put the magnifiers on, and I'm going to turn it around a little bit so I can actually use the needle nose plier and kind of wiggle it in place like that. So now you might be able to see right there, the cotter pin goes through the two little holes in the back end of the solenoid bore to contain the brass washer and the cushion and the plunger and the spring, so it can't come out. Now, a lot of times with cotter pins, and people have experience with this, it's usually something that's auto related, and what people would do is take these ends, the straight ends that stick out of the tube, and bend them over. But that's not the way it was done here. It was done differently than that. And what they did was they used a tool of some kind, and they inserted it between the two halves of the cotter pin like this inside the solenoid bore, and twisted it. And now I need to get the bigger screwdriver, because we have to twist it even a little more. And I'll turn that so you can see it. And what you end up with here, right here, which I think you can see, is it's elongated inside the solenoid bore. It's sort of roughly diamond shaped, not exactly. And I'm sure they had some kind of special tool, or maybe they didn't. Maybe they just had a plain old screwdriver and they put it in there and twisted it. But it's a quick, easy way to contain everything, and easy enough to take apart once you figure out the best way to do that. So now solenoid number 4 has been reassembled, and our chime is almost complete. Okay, so chime's all reassembled except for the cover plate, so you can see how it operates. And what we're going to do is I have it connected up to transformer power here, and what you need to watch are the 4 solenoids. One's here, one's here, one's here, and one's here. And my little yellow wire here, this is going to act as our push button wire, because that's just a quick, easy way to do it. So we'll make the connection on terminal C, and if you watch, you'll see the disc start to turn. and it stops. It ran through its cycle. So the way this operates is, right now it's in the starting position, and the little switch right here is open because this half of the switch where it's bent down is in the notch, so it's not being pushed up from the outer edge of the disc. And that when a visitor comes up and pushes the button, which is like this, they push it long enough to cause the motor to begin to turn. And once the motor has turned enough that the outer edge of the disc pushes up on the switch right here, then as long as the switch is closed, it will continue to run on its own after the visitor's taken their finger off the button. And I can actually show you that because instead of using the yellow wire, if I just push up on the switch, it begins to turn, and now the edge of the disc is holding the switch closed. And as it comes around and it hits the notch, the switch opens and it coasts to its starting position and it's ready to go again. As the disc turns, this springy contact wipes against these different posts, and as it does that, that's what causes the coils and the solenoids to energize and makes the plunger pop out. So if I do this, if I jumper across this, it makes this one pop out, because that's the first note. And if we go down here to this one, it makes this one pop out, and this one makes that one pop out, and this one will be the last one, which I believe is here, like that. So it's a fairly simple and elegant design. This chime didn't have a lot wrong with it. Mostly, it was just really old and really dirty. The edge of the disc was all gummy and kind of in bad shape. The contact here had a lot of carbon buildup on it, and really only half of it was exposed. The other half was pretty much covered up. These posts had a lot of grime and buildup on them, and it's just an old chime, so those are the kind of things that go wrong with it. At the end, I'm going to put this back on here. And the thing that's really nice, another small attention to detail, is this post, this post, this post, this one, and this one. These are all solid, and I believe these are copper or perhaps copper plated. These are all solid. The ends are closed off, but this one and this one are hollow, and they've been threaded to accept the little tiny machine screws that hold the plate in place. And again, it's a nice attention to detail because that's how things were made back in those days. Not so much like that today. It's just an interesting look at a really old Rittenhouse door chime. And I'm pretty sure that when Katie gets it back and puts it back up in her home, I know she has to put new cord on the tubes because they're all broken and wrong. So I'll send her some cord to make new tube hangers with. And she can enjoy it and relive her childhood like when she was growing up in her parents' house in Akron, Ohio. I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.